Hello and welcome to this WebEx video posting for the Temple University NASA Lunabotics 2014 electrical team for Temple University's senior design. This is the WebEx posting that is due Friday, November 15th, 2013. My name is Mark Halberstadt and I'll be taking you through this. I'm representing the team, which is myself, Mark Halberstadt, Eric Schisselbauer, and John Morris, and our advisor is Dr. John Helferty. And again, we are the Temple University NASA Lunabotics 2014 electrical team. So what I want to do in this presentation is I want to go over the electrical team goals, kind of the overall goals that we have for the work that we're going to be doing throughout senior design. I want to go over the progress that we've made on those goals, and I also want to show what some of the next steps are that we're going to be taking. So the overall team goals that we have is to design and build power and control and communicate, communication systems capable of driving a lunar mining vehicle through a harsh lunar environment. This is still our number one primary goal. We have to design and build all of the electrical systems needed for a robot capable of driving through a harsh lunar environment. Our secondary goal, which is still, it's a very much, it's still kind of a core primary goal, is to complete, is that this robot has to be completely autonomously functional. We have to just be able to push go, and it does everything it needs to do without any human intervention. The third goal is to increase the power efficiency of the system and also hopefully to reduce the size and weight of our power system, specifically the size and weight of the battery that's going to be on our robot. So the overall progress that we have made thus far really has to do a lot with a testing platform that we were very graciously allowed to use by the autonomous lawnmower team from last year, from the Temple University 2013 senior design. The team very graciously allowed us to use their platform, and we've actually been getting a lot of use out of it. It's helping us out a ton on this project. So the overall progress we've really made thus far really does concern very much this testing platform. So in our first video, we set out a schedule. We said that by November 1st, we were going to be able to ping our control system on the robot, that we would have remote login working for this control system, that we would have a Java virtual machine working on the Raspberry Pi that was going to be on our robot, and that we would be able to directly control this robot. And in this video, so this is going to be posted on November 15th, I'm happy to report that we were able to meet all of these goals. Unfortunately, we didn't meet them exactly by our deadline of November 1st. We did not accomplish this completely until November 5th, but we have completely accomplished these goals, and we seem to be everything on the testing platform is really going quite well. So anyway, what I would actually like to do now is I would actually like to show you a video of the testing platform. The audio might not be great in this video, but I want to show this. It's 1 minute and 45 seconds long that pretty much shows our testing thus far on the platform. Okay, so in this video, I just want to demo. We have a testing platform working. This is the autonomous lawnmower testing platform working. And essentially, what we've got is we've got a tiny little Java program that'll drive the robot forward, backwards, have it turn in place either left or right, and then there's a stop button in the middle. This is a Java program that's running on a Raspberry Pi. We're using VNC to control the Raspberry Pi right now, but as you can see, laptop is connected wirelessly, the Pi is wireless, we have the power system working now, and so now I'm going to drive the robot forward. So you can see the robot drives forward, I'm going to turn it right. So as you can see, it's turning right, and now I'm going to stop it right there, and now I'm going to drive the robot forward again. So anyway, that's just kind of a basic demonstration. It's driving backwards right now. We have a little bit of work to do to even out the drive. I have a feeling if I'm able to adjust the gain on the motors, it'll work a little bit better. That's pretty much it. We have integrated in the red stop button for turning this off. We're going to clean up all the electronics over here soon. But we have integrated in the red stop button, so this is actually working. It's making it nice and safe for us to test. A buck converter is being used to step down 25.9 volts from the battery to 5 volts, which can be used by the Raspberry Pi. Raspberry Pi is supplying the power needed for the Arduino, and the Arduino is basically supplying the serial data that's being used to control our motor controller. So anyway, I guess that's pretty much it. Thanks for watching. Okay, so anyway, that was the video that pretty much demos the progress that we have made thus far on the autonomous lawnmower testing platform. As you can see, there were elements of power. We were using a buck converter to step down voltage from our 25.9 volt battery. There was clearly control problems that we needed to work on there. We were controlling an Arduino, communicating with an Arduino from a Java program running on our Raspberry Pi single board computer. And there was also clearly communication problems there that we needed to solve, where we were wirelessly controlling the entire system. So anyway, moving on to stuff other than our testing platform, or stuff that has not yet made it to the point of where we can test it integrated with the testing platform. We have also changed the algorithm slightly that we will be using for filtering data from our Wiimote system. Our Wiimote system is going to be the method by which we are going to track an infrared light beacon, which we are going to place on our robot. We're going to test this by placing it on the autonomous lawnmower test platform. The algorithm that we are using to filter out the light beacon on the robot, as opposed to extraneous light from the environment, is actually being altered somewhat. We're going to use a particle filter. Localization algorithm in order to determine which light is coming from the beacon and which light is coming from the surrounding environment. So we have not begun testing that yet. We are still in the implementation stage, where we are trying to just implement that algorithm on an Arduino Uno right now. So our next steps for this project, first for the power system, we want to begin integrating in a current measurement system into our autonomous lawnmower testing platform. This is really important for a couple of reasons. First off, it's very important because we have to do this for the competition. It's also very important because a large focus of the power problem of this project is we want to explore options of possibly reducing the size and weight of our battery. It's going to be very difficult to do that unless we have a very accurate measurement of the current we're actually consuming during our testing phases, and we're very confident that those numbers are actually right. So we really have to begin integrating in a current measurement system into the testing platform. We need to really do that immediately so that we can work all the bugs out of it. For the communication system, we want to optimize a TCP client and server program such that data can be moved between all connected devices. Right now, it's working very well for moving data from our command center PC, as you maybe saw in that video. It's working very well in terms of moving data from a command center PC to the Raspberry Pi running on the robot. However, we still have work to do in terms of generalizing that such that any device can connect into that Raspberry Pi and request bits from it, or the Raspberry Pi can send it bits, or that other devices can send bits to the Raspberry Pi on the robot. And then finally, for the control system, we want to complete our initial testing of the data filtration system of our Wiimote using that particle filter system. So anyway, I guess what we want to do is we want to set ourselves another schedule, and by November 22nd, so this is 1 week away, We want, and this is the date that for senior design we have to have our prototype is due. Essentially, our preliminary prototype is due on November 22nd. And in addition to the work that we've already done with the autonomous lawnmower testing platform, we want to be able to read electrical current data from a measurement device, and it's a measurement device that we already have, into an Arduino board. So we want to be able to do that by November 22nd. We also want to be able to implement a TCP server on the robot control Raspberry Pi, such that other devices and generalized devices, not just the command center PC, will be able to connect to that Raspberry Pi and send it bits or request bits from it. We also, and then finally, we want to conduct initial testing on our Wiimote system that's using the particle filter. So those are our goals for November 22nd, the due date of our prototype for Senior Design 1. And that concludes this WebEx posting. If you have questions, please feel free to email me. My email address is c.mark.halberstadt@temple.edu. And you can also leave comments in the WebEx interface for this video. Thank you so much for watching, and I guess we will see you in the next WebEx posting. Thanks so much. Bye.